This is a lesson that reviews factoring that we'll need to know for the next chapter, chapter 9.4. And so we'll review a couple of factoring methods. And the first method we'll review is factoring out a greatest common factor. So the first example, 2x squared minus 4x, we're going to look and see what number can we divide out of both 2 and 4. And so we'll find that we can factor out a 2. And then if we notice that there's also an x in both of the problems, or both of the terms, we can also then factor out an x. So our greatest common factor here will be 2x. And then what we're going to do when we factor out a greatest common factor, all we're doing is undoing multiplication. So we want to say, what would this 2x get distributed into to fill in our parentheses? So if I think 2x times x would give me 2x squared. That's what I want. That's my first term over here in the original problem. And then what I'll do is I'll say, what times 2x would give me 4x, or minus 4x. And so I'm going to write in minus 2. And when I distribute my GCF, my greatest common factor, into the parentheses, I get 2x times x, that's 2x squared, minus 4x. And as long as what I multiplied out matches what I started with, I know that I factored it correctly. And so completely factored form would be right here with the parentheses. This is just my check. So again, I'm going to multiply to check. So my second example down here, I'm going to factor out the greatest common factor. There's a 3, and then I can also factor out the x. I want to factor out the smallest x possible. So 3x, and then what would I distribute that to? Well, 3 times 2x squared, 3x times 2x squared makes 6x cubed, minus 3 would make 9x. So this is my factored form for that problem. We'll also review factor by grouping. The key here is that generally there's going to be 4 terms, and the way we factor by grouping is we split those terms in half and we group together the first 2 terms and the last 2 terms. And I'm going to factor out the GCF from each side. So here I can factor out an x squared, that's the smallest exponent, an x squared. And left inside, what would I distribute that to? X squared times x plus 3 would get me back to the original problem. Then I'm going to go to the other side, and I'm going to factor out a greatest common factor over there. And the goal is I want my parentheses to match. So whatever I have over here, I want it to be an x plus 3. And if I factor out just a 2, I'll have a minus. I'll have both of them be negatives. So what I'm going to do is factor out a minus 2. And that'll change the signs. And minus 2 times x would give me minus 2x, and then times 3 would give me minus 6. The last thing I'm going to do is write my answer. And my answer will be x plus 3, the expression in the parentheses, and then x squared minus 2, the expression, or the terms that I factored out. The x squared minus 2. And that's my final answer for that particular problem. So this next one, again, we're going to split it down the middle. I'm going to factor out the greatest common factor of x squared, and that leaves me with x plus 5. And then on the left, I have the same problem of the signs that are not going to match. I want to have an x plus 5. Here I have a minus there in the problem. So I'm going to factor out now a negative 1, and that will change the signs for both the x and the 5, which leaves me with this x plus 5, and then x squared minus 1. And since this is a factoring review, hopefully we can recall that when I see x squared minus 1, I should think of difference of squares. So I'm going to factor this again. I'm going to keep the x plus 5, but then this expression breaks down into x plus 1, x minus 1. And this actually will become my final answer. We also want to review factoring trinomials. And the way we factor trinomials is we think about FOIL. First, outside, inside, last. And so I'm going to be starting with 2 sets of parentheses, and my job is to fill in those parentheses. So the way that I do that is I'm going to focus first on these outer terms, the x squared and the minus 5, because the numbers that I choose to fill in my parentheses will be the numbers that multiply to those 2 terms. So x squared will come from x times x. That's a pretty easy one to figure out. And then I'm going to think about numbers that multiply to 5. I have 1 times 5. And then I'm going to realize, hey, this is a negative number. And the only way I can multiply to a negative 5 is if I have one positive and one negative. So I just write in a plus and a minus into my parentheses. We'll figure out which number is plus and which number is minus in just a moment. So then what I'm going to do is I'm going to guess and check. I'm going to play around with my 1 and my 5. And I'm just going to put them in anywhere. And now I'm going to FOIL. So I get x squared. First, outside terms, x times minus 1 is minus x. Inside terms, plus 5x. Out and last terms, minus 5. Now I have my x squared, I have my minus 5, and then I'm going to see, okay, what do those add up to? In the middle I get a positive 4x. I need them to add up to a negative 4x. So what happens is I have the right number, so my numbers work out correctly, but since it's a positive instead of a negative, what I need to go do is now change this, change my signs, and switch them around. So instead of x plus 5, I'm going to write x minus 5. And instead of x minus 1, I'm going to have x plus 1. I'm going to switch my signs. Because now, if I do that, if I switch them, if I switch those signs to minus and plus, what happens is now I get a plus x here and a minus 5x, which makes this a negative 4. So this is the correct factorization. It should always multiply back into the original. We're going to multiply to check. Always, always, always. So now let's try this next example. I'm going to draw my two parentheses. I'm going to think about my first term and my last term. X squared comes from x times x. And now to get a positive 6, I could have 1 times 6 or 2 times 3. I'm going to always check the ones closest together, the 2 and the 3, first. And now I'm going to look at my signs. They need to multiply to a positive. Well, the only way I multiply to a positive is if I have a positive times a positive or a negative times a negative. Now I'm going to look and see my middle term. This will tell me which one of my cases it's going to be, the positive case or the negative case. I know ultimately my middle terms will need to add up to a negative number. That's how I know that in my parentheses I'm going to have two minuses, because that's the way it's going to add up to a negative somehow. And now what I'll do is I'm going to test out 2 and 3 first. And if they work, great. And if they don't work, then I can try 1 and 6. But we'll test 2 and 3 first, since the ones that are closer together tend to be the ones that are the answer first. So here we go. Let's FOIL to check. We get x squared, outside minus 3x, minus 2x, plus 6. My middle terms add up to negative 5. So my final answer is x minus 2, x minus 3. That is the factored form, and that is the final answer. So now let's factor a few more trinomials. This time we're going to have a number in front of x squared. So when I choose my parentheses, now I have to think about how do I multiply to a 6x squared. Well, again, I've got 1 times 6 and 2 times 3 as an option. Again, I'm going to try the ones closest together. So I'm going to write 2x and 3x. Now I'm going to go and play around with the minus 3. Because it's a negative, I'm going to write one of each sign. That's the only way we'll multiply to a negative 3. And this is nice because we only have one pair of factors that are a choice, 1 and 3. So I am just going to plug these in however I can. And now I'm going to test them and see if they work. So when I FOIL, 2x times 3x is 6x squared plus 2x minus 9x minus 3. And I'm going to check and see what do my middle numbers add up to. Negative 7x. Oh, I have the right number. I want a 7. I have a 7, but my sign is incorrect. So what that tells me is I need to change my signs. So I'm going to erase that minus 3 and that plus 1, and I'm going to replace them with a plus 3 and a minus 1. That'll change these to minus 2x and plus 9x, which changes it to a positive 7. So again, just to rewrite it, it's nice and neat. 2x plus 3, 3x minus 1 is my final factored form. And last but not least, for trinomials, we're going to factor this. I'm going to do some guess and check. 2x and x will multiply to 2x squared, and then to get 21 I have 3 times 7 and 1 times 21. I'm going to try the ones closest together first. 3 and 7, and I know one's a plus and one's a minus, so now let's check it out. 2x times x is 2x squared, minus 14x, plus 3x, I'm foiling to check, minus 21. They add up to negative 11 in the middle. I like it. I got lucky right off the bat. So this is my factored answer. We also want to take a look at a couple of special forms that we're going to see. For example, difference of squares. Here we're going to look for perfect squares. Perfect squares are numbers that have nice square roots. And we can make a list. We can say 1 squared. We can just punch it into our calculator and make this list on the side of our paper anytime we need to. 4 squared is 16. 5 squared is 25. And so these are perfect squares right here. They have nice square roots. Okay, we could go all the way up 6, 7, 8, you name it. Go as high as you need. And so what I'm going to do is look and see, hey, 16 is a perfect square. What got squared? 4. Or in other words, what's the square root of 16? Here we have an x squared. What's the square root of x squared? X. So once I figure out what got squared, those are my a and my b. I'm going to fill in my parentheses, and it's a nice little pattern. We're going to write x plus 4, x minus 4, and that's that. So down here with the second example, what's the square root of 4? 2. What's the square root of x squared? X. What's the square root of 1? 1. So 2x plus 1, 2x minus 1. And that's that. Last but not least, we have a special form called sum and difference of cubes. And just like with square roots, we're going to look for something called a perfect cubed. And we can make a list of perfect cubes on our paper. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and we could go on and on as long as we needed. But what we're going to do is when we see an x cubed in these problems, that's going to clue us in that maybe it's one of these special forms. And so what I'll do is I'll say, hey, do these numbers have a nice cube root? And if they do, I'm going to write that down. The cube root of 8 is 2. The cube root of x cubed is x. The cube root of 27 is 3. And so these become my a and my b. Then what I'm going to do is notice that in the middle I have subtraction. So right there, that tells me I'm going to use the difference formula. So the difference formula says this, a minus b. So I'm going to write that down. A, my a is 2x, minus b, my b is 3. Then it says a squared. So I'm going to take my a term, the 2x, this is a, and I'm going to square it. 2x times 2x is 4x squared, plus a times b. 2x times 3 makes 6x, plus b squared. B squared, 9. There we go. And I'm done. Once I use the formula, I'm done. I cannot go any further. And last but not least, what's the cube root of x cubed? X. What's the cube root of 64? 4. It has a plus in the middle, so I'm going to use the plus formula. So it says a plus b, x plus 4, and then a squared. So I'm going to take a, that's x, and square it, x times x, minus a times b, x times 4 is 4x, plus b squared, that's 16. 4 squared is 16. And I'm done. I can't factor that anymore. So that's how we use our sum and difference of cubes formula.
Made with Doodlecast Pro.